Okay, everybody, I think we'll get started here. Sorry to interrupt the good conversations. I'm glad you came to seminar and are having good conversations. But I want to introduce Eduardo Luquin. He's going to talk a little bit more about his background, but he came to us from Iowa State, and he has a lot of experience doing watershed modeling and thinking about erosion on the landscape scale. And he's going to talk about a very cool set of tools that is taxpayer funded, as he just reminded me. So he wants to make sure we are all aware of them and ready to use them. Thanks, Eduardo.
Thanks, Anna. Well, hi, everyone. For the ones of you that don't know me, my name is Eduardo. People also call me Edu. I find over the last years it's a little bit more easy for Americans to call me like that. People call me Edu in Spain. So I mean, all your emails at the end, Edu. So Eduardo, Edu, you can call me. So my last 3 years and a half, I've been in Iowa State. I was a postdoc over there, migrated north instead of south, like all people do. So far, I'm enjoying your weather. And during my time at Iowa State, I was mostly working on the daily erosion projects. And a lot of this funding is coming from Minnesota. And actually, a lot of my position, a lot of work that I've been doing over there, it was financed from Minnesota. I think it's a great project. I'm totally biased because I've been working with this over the last 2 years and a half. I think it's a great tool, and hopefully you can use it for your own research, and we can find things to collaborate. And we are also paying without taxes for this, so we better at least use it. I'm gonna mainly talk about three sections in this presentation. The first one is gonna be a little bit more the boring part. I'm gonna talk about the methodology. I want you to understand a little bit how DEP, Daily Erosion Project, is doing all the simulations, so you can more or less try to understand the numbers that we are suggesting. Then the more fun part is we'll jump into Minnesota. We'll just take a look what Daily Erosion Project is seeing or simulating in Minnesota, and if we have time, we'll see how we are doing. If needed, just cut me because I can probably go for like 1 hour, just like going into water sets and taking a closer look. We'll just jump into some examples on how people have been using the Daily Erosion projects in the past. So, massage your ears. We'll start with the methodology. They didn't get very creative with the name. Daily Erosion Project, DEP, is a daily estimator of 4 parameters: precipitation, runoff, detachment, and hill slope soil loss. We do not estimate precipitation. We just aggregate that, and just it's a way of providing that estimation too. But we report these values at the daily, and we make this publicly available at the HAC 12 spatial resolution. So we work at two resolution, temporal, every day. So today we have published what happened yesterday. Tomorrow we'll publish what happened today. The spatial scale is the HAC 12, hydrological unit code. I had a little bit of trouble here because here you guys use more the DNR HAC 12, but this is the USGS HAC 12 hydrological unit code. So all these polygons that you are seeing over there, those are HAC 12 water sets. A little bit of numbers. We are doing simulations of around 644,000 square kilometers every day. We simulate more than almost 7,000 HAC 12 water sets every day. And we are also simulating almost 1 million hill slopes every day. So you can more or less start like getting an idea of the scale of these projects. If you go into the website, dailyerosion.org, you will see this type of map. It's kind of like a Google style map. You can zoom in, zoom out. You can click in one of the water sets, and you can start seeing like some of the information that we provide for every day that we are doing these simulations. So this is an example of June 22nd of last year. If you recall, last spring was a little bit a wet spring, and there were some huge events in terms of hills of soil erosion. Hasn't been random, the selection of this date. We also provide a little more information for that specific water set. You can see the top 10 soil loss event days. I just picked that one by choice, so we can have a little more colorful map. And here you can see the summaries, the four outputs that we are providing: precipitation, runoff, detachment, and hill slope soil erosion. You will be hearing me saying hill slope a lot. We work only at the hill slope, okay? So whatever numbers I'm gonna tell you, those are hill slope erosion, okay? We work at the daily step, but the user can download or can play around with different temporal resolutions from days to weeks to months to a decade. We go all the way back to 2007. That's what I'm showing you here on the map. I'm just plotting hill slope soil erosion. That's what happened last year in terms of hill slope soil erosion on the entire DP domain. And you can start seeing like some different colors, right? Minnesota is more dominated by low hill slope soil erosion. You can see how we're starting to see some parts of Minnesota, some parts of Iowa along the Missouri River. And you don't see here, but on the east of Iowa, we also have more colorful map. So you can start seeing patterns. So we went from daily, now we're seeing like an annual total hill slope soil erosion. I could show you also this map for different outputs, precipitation, runoff, detachment. We are currently on agricultural land only. We simulate row crop, and we also simulating perennials. That's important to know. If you see the north part of Minnesota is empty, it's not because we don't like us. It's this reason. I'll talk about that later. It's also part of other states. Wisconsin, Illinois. I'm learning the states. Missouri, Kansas. And we are expanding to all these in the next 2 or 3 years. We also want to cover parts of Indianapolis, I think. Indianapolis? Yeah. Indiana. Where's the capital? Indianapolis. So we are expanding. So in the next years, you will see this big map, and it's going to be really interesting to see like all the parts of the state, because that's where it's getting fun.
Can you say what those units are? What's the I unit?
The yellow is between 5 tons per acre per year.
Okay.
Or this is just annual total. 5 to 7. The light green is 7 to 10. The dark green, this area over here in Iowa, is 10 to 20. And the bluish areas is 20 to 30. And the dark blue, I think these two waters over there, they're higher than 30. In the maximum I don't see here is 37.25. We're expanding in the Midwest. We are also expanding in Europe, I'm from. We are also expanding in China. So DP is growing not only here, it's growing internationally. So we don't do any magic. We just do like hundreds of simulations per water set. That's a simple way of saying this. The fancy way of saying is that we do a stratified random sampling approach. So basically, we take a look to one of the water sets. That water set is subdivided in smaller subcatchments. Those are those blue polygons that we are seeing over there. And we are stratified randomly sampling approach, selecting a hill slope per subcatchment. Okay? Simple way. We do hundreds of simulations per water set. This way, we just like distributing the hill slope throughout the water set. We do not sample every subcatchment. There's some more conditioning over there, but like we do hundreds of simulations. Yeah. It's randomly. Yeah. Yeah. You mean across the water set?
Then you're saying you're steeper and less steep.
No. Yeah. Yeah.
You might have said this. Is there one hill slope per subcatchment?
Not necessarily.
But usually.
No. Well, sorry. Let me correct that. We sample one hill slope per subcatchment. We do not sample all the subcatchments. I mean, it needs to be a certain amount of ag land on that subcatchment so that we are prioritizing that subcatchment. I mean, there's so much studies also on the 2017 paper. They studied like, what if we start sampling more? And they didn't found any statistical difference to sampling less. We have to keep in mind that we have to maintain and doing all these simulations at night. So we cannot just start like sampling as much as like 10 or 20 or 100 per subcatchment. So a actual water set subdivided in subcatchments, we randomly select a hill slope on each of those subcatchments. Depends on the water set, but on average, we sample between 75 and 100 hill slopes per HAC12 water set. I forgot to say those yellow lines are the hill slopes that are randomly selected. And this is how the yellow line will look in the field. I just made this figure. So we are only simulated the yellow part of the field, hill slope erosion. We are not simulating the black lines, concentrated flow erosion. Hopefully in the nearby future, we'll be able to do that. Right now, we are only simulating that part. How do we do that? We use the water erosion prediction project. This is how it looks in the field. This is a simplification how it will look in the model. Okay? Web project, water erosion prediction project, is a USDA simulation model to model soil erosion by water. So we execute the hill slope version of web in order to obtain these daily estimations. There are three main reasons why we choose web. The first one is that it's physically event-based and allow us to use real climate. Second one, it has been rigorously tested, has been proven to work without calibration satisfactorily. The third one is that allow us to capture like the landscape variability. So every time we have soil change, a land use change, and land use management change, we're able to capture that along the profile. So we have a change on soil here, we are able to capture that. So it gives us a lot of flexibility in order to be as real as possible with simulating these hill slopes. So these are the four major components of DEP. The inputs, which are divided in meteorological databases and geospatial databases. The main motor of the model, which is the web model. And lastly, the sampling and scaling approach. How we are just summarizing all these hundreds of simulations per water set and how we are providing the results in the morning. So all this you have to keep in mind is done at night. So let's talk a little bit about the climate. The climate is done by the Iowa Environmental Mesonet. It provides precipitation and other meteorological information in the format that the web model needs. We use NOAA multi-ride, multi-sensor Q3 products. And this is what I'm showing you here. This is just Q3 product for May 21st for the state of Minnesota. We have the raster at a 2-minute resolution, 1 kilometer by 1 kilometer raster. Later on, there is some quality control using later corrector multi-ride, multi-sensor. And also we use stage 4 and prism. All the meteorological variables like wind, temperature, solar radiation is provided as a coarser resolution, 25 and 25. So at night, as I told you, DEP start like calling for what had happened yesterday. And it's starting to create all these inputs to be run at night. All this code can be seen on that GitHub page. Daryl is the one smiling here. It's probably smiling because I'm the one explaining the climate, he is the expert on here. But this is like publicly available, and you can also have access to these Q3 products and climate products. So these other inputs, again, are just obtained for each hill slope. We use the 3-meter DEMs derived from LiDAR. Sometimes we know that LiDAR doesn't like to flow, so we have to hide and force this LiDAR. That's what I'm showing over here. So DM needs to be hide and force. We are also capturing
natural impediment flows such as terraces or wascops, where the actual the hill slope will stop, and those are where like those points are suggested. So we are accounting for that type of structural practices. We do not jump over terraces or over wascops, water and sediment rotation basins. The second of the geospatial inputs are soil information. This is derived from GSURGO. Actually, we obtained this from the Agricultural Conservation Planning Framework. We have Sarah Porter here. She's the expert on that, so she can explain that a little more. But the soil information for each of those hill slopes that we are simulating, that yellow line over here, and you can see, for example, in this example, how that hill slope is crossing 3 different soils. So we are able to capture those soils along the profile. The ACPF is also providing all the soil information to create web soil files, soil texture, coarse fraction, organic matter, and cations exchange capacity. The web model uses some data transfer functions in order to calculate other soil variables. I'll just quickly mention something about the ACPF. The ACPF is a framework that provides training and provides support for conservation practitioners in order to locate the most vulnerable parts of the watershed, to locate BMPs. This is the extension map as that is on the manual as March 2022. So you can start seeing some synergies of this. Daily Erosion project is simulating all this part and is extending to that other part. So actually is gathering a lot of the inputs from the ACPF. So these inputs are also available. The ACPF is a framework. It provides this training and this support for conservation practitioners. It also provides a set of GIS toolboxes in order to locate these most vulnerable areas, but it also provides geospatial databases, provides field boundary information, the GSURGO raster that I just told you, provides also more soil information and crop rotation for those fields. So all this information is then processed and used by DEP in order to locate and to obtain the inputs to run web on each of those fields. So again, we have the yellow lines, those are the hill slopes that we are simulating. Keep in mind that the hill slope can cross to fields. So it could potentially have a different management. The DEP uses ACPF field boundaries, which are derived from 2008 FSA common land unit. Those are manually edited using the night border photos and the crop data layer. You could imagine the amount of work that this is that needs to be done to use manually edit all the fields in our watershed and all the watersheds in the state. The cropping sequences is what I'm showing you over there. So the ACPF is also providing cropping sequences. There's the cropping sequences are derived from the crop data layer, and that's what we're seeing over here. Those are just for the last 6 years. The Daily Erosion project uses a special crop sequences that goes all the way back to 2007, and all the plant parameters they are obtained from the web model, like growing degrees days to maturity or the biomass radius and other plant parameters. So we talk about the land use, and this one is a little bit tricky. Now we're going to talk about how we assign the management for each field. And in a way, we don't know. I like to say we pretend to be farmers. We don't know what the farmer is doing. So we have some tillage management scenarios that we assign. We need to assign to each field which operations we are doing and which days are we doing those operations. We don't know. That's a simple question, but we pretend to be farmers. I call it digital farming, for example. So how do we do this? We know that the soil and the residue cover reflect differently in the middle infrared.
So we use these custom-based algorithms that were obtained from satellite images, Landsat 8 and 9, and Sentinel-2s. In addition, with ground-truth data, in order to obtain this algorithm, that basically is telling us the spring residue cover. That spring residue cover, we translate into one of the 6 tillage management scenarios that we have in DEP. Those are just assigned by a different code. Here you have an example of what we do on a corn soybean rotation. The higher the number, the higher the tillage intensity. Just not just in the number of passes, but also in the type of operation. For example, number 2 is the spring field cultivate, planting, and also chisel plow before corn. So it's not the same spring field cultivate than a mobile plow. The higher the number, the higher the intensity of the tillage. So for example, if we have a 30% residue cover in our field, we know the last year we have planted soybeans. Then we know we will likely use tillage code 2. If last year was corn, that 30% residue cover, excuse me, is not the same as the soybean. So we will likely assign a little more intensive scenario. That's how we assign these tillage management scenarios. So once we assign that, now we have to think, okay, when are we gonna do these operations? When are we gonna plant? So until last year, the entire state of Minnesota was planted in the same day. Corn, one day, soybeans another day, wheat another day. We know that's not true. So again, what we do, we just pretend to be farmers. We don't know what do we do, but when we go to sleep, we need to know if we are going next day to the field, and we just bring our tractor, our equipment, and we're going to start planting. How do we do this? We use a field workability algorithm. We call it dynamic spring planting and tillage approach. And basically is what I'm just telling you. Pretend to be farmers. At night, we have to check what are the field conditions, if we are going to the field conditions, or if not. So 2 years ago, the entire state of Minnesota was planted on the same day. This is how corn was planted last year. So remember that we simulate between 75 to 100 hill slopes per water set. What you are going to see here is the planting progress of Minnesota, like what is the planting progress of each actual water set. Let's see if it works. So we can see how it's not static anymore. The planting of each water set is based on field workability conditions. So based on the temperature, based on the soil moisture conditions, and based on the precipitation. Again, we go at night, we check those 3 with this algorithm, and we know if we're just going to the field and plant. Keep in mind, we do this like overnight. We like to be really good farmers, so we only enter to the field when it's like the perfect conditions. That's not true. Like after June, I think after June 11, we just plant. Well, I have to say, Minnesota is using its own residue cover product. So Minnesota has its own residue cover algorithm. So this project was funded by Bowser. The title of the project is Assessing Soil Residue Cover, Cover Crops, and Erosion using Remote Sensing and Modeling. The main objective of this project was to generate this database in order to have better inputs that I've been showing you for the daily erosion project, with the end goal to have better estimations of the daily erosion project for Minnesota. So Minnesota has a total of 4,600 ground truth data points, residue cover photos that we have all the way back to 2016. Every year, an average of 4 counties are sampled for residue cover photos. The ground truth data, in combination with the satellite images, Landsat 8 and Landsat 9, and Sentinel-2 satellites, we create a custom algorithm for Minnesota. So with that, we train the model to obtain the residue cover for these fields. We apply this residue cover algorithm to the rest of the state. So the end product, and this is just aggregated by Hack12. I think this is the DNR Hack12 resolution. It's not like USGS, but it's more or less similar. We have per field in a way, but here is just summarized by Hack12. We can see, however, here the residue cover has different value, but overall we can see a trend how this residue cover is increasing over the last years. And this is good for the daily erosion pair, so then we can capture this pattern into the simulations. And obviously the values are different whether you're having more or less residue in the fields. It's important to know, like Minnesota has its own residue cover. So that's pretty much all the 4 major components of the daily erosion project. This was the worst part. I'm sorry about all the dumping all this information on you. But now it's going to be the more fun. I'm going to skip this one. If you have more questions, I can go back. But I wanted to go a little bit into the daily erosion project website, so we can take a look to that together. I think the people online, they will still be able to see my screen, right?
People.
Okay. So if you go to a daily erosion project website, I mean, I'm not affiliated with this. They're not paying me for encouraging you to go to this website. But you can go to interactive map and you can start playing around. So here we have what happened yesterday. And tomorrow you have what happened today. So we see there's not much going on in Minnesota. But I'm going to do, well, this is not working very well. I want to do a trick. Just selected one water set. Happen to select like one with a very difficult name. Don't make me pronounce that one. Chanarambier. Sorry about that. Let's get one of these. So if you double click in one of the water sets, it would show up like the top 10 events. So let's go and take a look to one of those. This is not working very well. So we can see the summary of what happened that day, the 4 estimations the DEP are doing for that day. Precipitation, 3.6 inches, runoff, 3 inches, detachment, 0.55, hill slope soil loss, 0.55. If we go to here, we can also get different data, different temporal resolutions, what I told you before. If you want to go back to what happened in 2024, what I just saw you, you just select that amount and it will just update the map to the specific time frame that you have selected. So now we're just seeing like a different temporal resolution. You can download this data. You can download the daily values for that specific watershed that you have clicked, what we simulate every day. You can also download an aggregated value is the annual total. And I don't know why I cannot really see these graphs. This is just like a monthly averages of the 4: precipitation, runoff, detachment, and soil loss. So you can see, well, in this case, this water will have a lot of like hills of soil loss, but we'll see how May and June are the main months where we have this same in export. What else? You can also download the data. You can download the data. It downloads CVS with the Hack12 for the entire domain that you are selecting. If you are selecting only Minnesota, you only download the Hack12 for Minnesota. And it will just download the results for that specific time frame that you have selected here. It only provides you the save file with the Hack12 boundaries, as well as the precipitation, runoff, detachment, and hill slope soil loss for that time frame that you just selected here. If you go to the home website, the home tab, if you go to documentation, you can see a little more explanations, especially the meteorological data. How do we do those things here? So you can play around and have fun. And if you don't know what to do at 6 a.m. or 7 a.m. every morning, you have something new to do. You probably have better things to do, but okay, let's go back to the presentation. So let's talk a little bit about Minnesota, how DP, what DP is seeing in Minnesota, or what at least is simulating in Minnesota. Before I jump into showing you maps, we're just pointing like the most erosive parts of the state. This has been possible because of the state has been funded the expansion of the daily erosion project into Minnesota. So over the last years has been funded like many different projects, but overall to create these hill slopes we need DMs. So like DEP has been working on the hydro condition of these DMs. I told you before, it's not that we don't like that north part of Minnesota, it's beautiful. But that part is dominated by forest land. So Bowser is also funding the project in order to incorporate forest land into daily erosion project. So very soon, hopefully next month, we'll have estimations for forests too. We don't have a lot of hills of soil erosion in forests. We have more concentrated flow erosion, but DEP is migrating from the hill slope version of WEP to the small watershed version of WEP. And that has channels. And what do you need? You will need also like good DMs that flow for channels. It's also very important if there is a fire on that forest. Keep in mind what we were simulating the agricultural reality on the field. We pretend to be farmers. But it would be really interesting if we know that a hill slope, for example, a part of a watershed has been burned. So then you will have hills of soil erosion. So you will be able to capture those dynamics too. Oops. Another important project funded by Bowser is the addition of wind erosion. I will show you some maps, so there's not that much hills of soil erosion in Minnesota, which you probably know that. But this part over here, oh, well, I'm assuming that you know that you have a Minnesota shade forest, right? How amazing is cool. That's pretty cool. Anyway, so this part of the state is more prone to another type of erosion, wind erosion. So we also want to incorporate that. We are working, and Brent was working there like some years ago about that, incorporating the sibling of WEP is the single event wind erosion program. We have some challenges with this because we need much more information that we need from the for the web model. We need road direction, we need wind breaks, and we also need stable height. That we don't know that information from daily erosion project, but we are trying to obtain that information from the simulations. And the last but not least, I already talked to you a little bit about the dynamic tillage and planting algorithm that pretend to be farmers when we go to sleep and know if we are going next day based on field workability. Here I'm just showing you a comparison with the NASH planting progress. So every week during the spring, the NASH is providing the planting progress of the entire state of Minnesota. The dots represent the planting progress of NASH. The line represents the planting progress of DEP. That fancy map with a lot of colors that I showed you before. So we have validated and have satisfactory results with the statewide number, but statewide number is really, really wide. Iowa, we have crop report districts. So Iowa is subdivided, I think 6 or 9, I don't remember. So we have a little more fine resolution over there. But we are working also on validating that with some of the ground truth data, some of the photos that we have from the residue cover, because we know if that field was planted or not. So all in all, this project has been trying to make DEP more Minnesota friendly, and in a way is fine-tuning the erosion project to have better estimations in Minnesota. So this is what you want to write down. If you write a post, I think you knew that we don't have a lot of hill slope soil erosion in Minnesota. So the statewide number for the entire state of Minnesota, and I'm only talking about these water sets, we are just focusing on what we call the 67, how many agricultural counties in Minnesota. Daily erosion project is also simulating some water sets over there. Those are more pastoral, perennial dominated. I remember like we are not simulating forests yet. So the statewide number long term, which is obtained from the simulation between 2008 to 2024, 17 years, if you can call that long term, is 0.62 tons per acre per year. That's a statewide number, which is really good. Awesome. Now the bad news. That's a statewide number, but I don't know if you can take a look to the maps on the right, but there are some parts of the state that are eroding more than others. And that part is actually coinciding with more rolling hills, also with more correlated with the rainfall pattern too. So there are some parts of the states that are like, especially these areas over here. This is detachment, which tends to be higher than hill soils. So all this part of the state is simulated like close to 5 tons per acre per year. Long-term average 2008, 2024. USDA soil tolerable level T levels. This is just a threshold, 5 tons per acre per year. So we are reaching that sustainable threshold. Some people are debating that we should put that down, which we might. But if we put that more down than 5 tons per acre per year, we can see especially that part of the state not being very sustainable over the long term. And this is tricky because we are just talking about long-term averages and everything is aggregated. Well, we can start taking a look to different years. And obviously, different years, different precipitation, different crops will provide different estimations. I like to put some dirt metals. And well, we are not putting the metals for Bowser, but these actual water sets can be aggregated at different spatial resolution. So if we aggregate this by county, we can see every year which county had more, like at least simulated hill slope soil erosion. So we have the dirt metals for the last 5 years. You can see a name that is repeating over there. So I'm trying to introduce you the annual total soil erosion numbers. Here's just an example of the last 5 years, 2020, 2024, precipitation, runoff, and hill slope soil loss. You can see how the precipitation pattern, this is just total precipitation, is different every year. You can also see how the runoff pattern is also different every year. You can see how this high precipitation produces more runoff. I'm talking about totals here. And it produces also like 2 to 3 tons per acre per year. But with less precipitation, less runoff, we have this area, water sets with 3 to 5, a little bit higher than 5 tons per acre per year. So you can start seeing water sets that should be prioritized. And my main point with this is that every year is different. If you remember, like last summer, you see this part of the state and actually it rained more on that other part of the state. Didn't produce a lot of runoff, but the numbers are really high. Why? I can tell you a story now, but like with this kind of simulation, we can start making a story or going backwards. There's also a lot of seasonal variability. The soil is more vulnerable around planting, where the soil is bare soil. So there was a lot of storms over there around planting, well, around June after planting. So I tried this before and I didn't work, so I'm gonna just go to the, well, let's do this. Let's see if it works. So you can go to the website and start downloading there you go. Start downloading the annual data. If you want months, you can also download months. but it is a little bit tedious. Okay. So what we are working now, we are working on digesting these products a little bit more for you. So what I'm showing you here are those same products that I just showed you before: precipitation, runoff, and hillslope soil loss for the entire state of Minnesota. So we will be working with the Minnesota Soil Health Office in order to widespread this dashboard. We are now migrating from Power BI to Tableau. This will also be able to access in the Daily Erosion Project website, but everyone can start playing around. Okay, what happened 2014? I don't know if it's going to work, but those maps should be like starting to show different patterns. If you want know a little more about a specific water set, you can also click on a specific water set. This is really small. And you can see the numbers that DEP is simulating for that year, annual total of that specific water set. What happened in 2022, a different one. What happened in 2010. So I think in the next months we will be able to share this with everyone, and you can start playing around with these numbers. You will also be able to download this more digested product, those annual estimations, so that you don't have to be downloaded like every year at the Daily Erosion Project. So this is what I had to show you about Minnesota. How I'm doing with the time. 15 minutes. Well, let me just say a couple more slides. So a while ago, the Daily Erosion Project team, they were wondering like who uses DEP. So they found out that a lot of people are using Daily Erosion projects, from agency, federal to state, farmers, education at different levels too, universities, schools, scientists, but they all had in common one thing. They were just concerned about soil resources. So Daily Erosion Project has been used in many different ways. We mostly use DEP for scenario evaluation, but what I've shown you now with these maps and these patterns, DEP can be used to focus resources. It can also be linked to water impairment areas. We do not simulate flooding, but we do simulate runoff. Could you link that to a flooding event? Keep in mind that at 6 a.m. we are just providing you that output. And some other people have been using Daily Erosion Project to validate their own simulations. That's when we just got scared. Like, well, people are using our data, so we better do a good job. Especially a lot of like large scale Russell continental models they're using are comparing to Daily Erosion Project. So quickly have two examples for the scenario evaluation. What if scenarios? What happened if we replace the 16 land use and management for switchgrass? We evaluate, well, not we, they evaluate 3 management scenarios. What if we target hill slopes that are higher than 3%, hill slopes that are higher than 6%, and hill slopes that are higher than 10%? This was just done for Iowa. So as you could imagine, and this is not working. Oh, yeah, it's working now. The blue line represents the baseline. This is what happened in Iowa if we continue with the actual cropping system. This was simulation between 2008 and 2017. So these numbers might be different now. But here are the 3 switchgrass scenarios targeting steep slopes, 6% slopes, and 3% slopes. So just with the more steep slopes scenarios, we're just reducing Iowa statewide number like more than half, from 5 tons per acre per year to close to 2 tons per acre per year. So my work during my postdoc at Iowa State was related to what if scenarios. So a question that we asked the Daily Erosion Project, this is currently under, well, we are almost about to send this for peer review And that's why I'm not showing you the entire DEP domain. I just focus on Minnesota. But what happens if we don't allow the daily erosion project to use, for each hill slope to use its own management? What happens if we start tilling more? So these are what the model is telling us. So basically what we are doing, we are forcing all the hill slopes to be no till. We are forcing all the hill slopes to be till scope 2, spring field cultivate, plant, and including a chisel plow before corn. 3, 4, 5, and 6. The higher the number, remember, the higher the tillage intensity. Not only the number of operations per year, but also the operation itself. And we found quite some interesting patterns. Like obviously, if you have no-till systems, everything is green, which is really good, right? We like green. But the moment we're starting to till, we're starting to see some more colors on specifically in Minnesota. You could imagine, based on the maps that I showed you before, how the other states will look the moment that we start tilling, specifically those hill slopes areas, those hilly areas. So the more we till, the more colorful we are seeing those water sets. I don't know if you can see, but this is just metrics because it's for the publication, but the pink reddish water sets are above T. Those are 11.2 megagrams per hectare per year, 5 tons per acre per year. So we can start like targeting those areas. This red keeps like expanding like across Iowa. So this is a proof in a way that no-till system minimize soil loss and maintain the agricultural landscape at sustainable rates. We also have seen this like a significant spatial variability response of the water sets across the DEP domain. You don't see a lot here, but you can see how some parts of the state are starting to erode more if we till more. And I'm just focusing on hills of soil erosion. We didn't really take a look to any other soil health parameters. You can see the more we till, how some parts of Minnesota are starting to also to erode more. So this is an example of focusing resources. So last year was our 10th year anniversary. So we did something like more fancy for our 10th year anniversary. Well, the DP started like back on the 90s, but the actual DP domain has 10 years, those 8 states that I just showed you. So we developed this tool we call the OFE tool, and this could be a total different seminar, but basically what it's doing is downscaling the daily erosion project from a hectare average to a field average. And we know the fields and the parts of the fields that are more vulnerable to hill slope soil erosion. So over the last years, like people have been complaining that the hectare of water set is very coarse resolution. Well, now we have a tool that we can see the fields and the parts of the fields for entire DEP domain that are most vulnerable according to that. That is intended to be part of the ACPF toolboxes. So you will be able to run this for any water set as far as the DEP is implemented over there. So just wrapping up now. I just show you some maps, and we know that some parts of Minnesota and the Midwest are eroding at unsustainable rates. I also show you some maps and evidence that DEP can be used to prioritize intervention on those water sets, not only DEP, but also this OFE tool. It's important to remember that DEP is not a true model, a true total erosion model. We are not including all the concentrated flow erosion processes. We are not including the thermal gullies. We are not including permanent gullies. We are not including stream bank erosion. We are also not including all the agents, wind erosion. We are also not including tillage erosion. We are also not including the harvest of root crops, which in Minnesota is also prevalent. So all in all, even though I show you a lot of green maps, a lot of green, there might be areas that might be even more. This is just part of the cake, what I'm just showing you over there. We need to evaluate this regionally, and we think that Minnesota is a great place to do that. There's a lot of good water quality data that we are intended to use to validate the data erosion project estimations. And lastly, how to access the data. You have there the link to the Daily Erosion project website, dailyerosion.org. And also, surely we will share with everyone here the dashboard that you can play around and also download the data. So what I show you has been a work ongoing since the late 90s, and there has been a lot of excellent researchers working on these projects. And you will see some U of M logos over there. Well, myself, but we also have David Muller. We also have Greg Wilson here. Well, now it is another department. We also have Brent that have been contributed to make Data Erosion project what it is today. So it's good to thank these people. Also thank the funding, especially for Minnesota, all the funding that has made possible to have a better DEP in Minnesota. And that's all I had to tell you about DEP. So what are you gonna do tomorrow at 6 a.m.?
Has anybody attempted to do any validation work on that?
People have validated the web model. David and Garner 2020, 2023 validated the web model using DEP inputs in this Minnesota Discovery Farms.
Oh, at the discovery.
Yes. The main challenge here is that we are just stopping at yellow arrow.
Yeah.
It's just like the soil that has been lost from the hill of the slope. People has been comparing to Russell.
Good approach.
I don't know. You're comparing two models. You might be comparing an apple to an orange.
Yeah.
But this need to have better like water quality data. And another thing is that with these field experiments, we have many other processes. It's hard to find a water set that is just dominated by hill slope erosion. You might have thermal gullies, you might have tillage. But we starting to have discussions about that, and we'll see. I think Minnesota has good data that we can take a look. Well, this correlate that to like water qualities. But so far they haven't have any attempt. There's a bunch of projects, articles with web across the entire US. And it works better once you validate it, obviously.
Well, I think using the discovery farm is a good first step anyway, and you could go to Wisconsin, there's more discovery farms there, so we might be able to.
Yeah.
expand.
Yeah, hopefully once it expands to Wisconsin, we can cover that area. Or we can just like sample over there and do that.
We found the model was doing a really good job. The only thing that was a little bit off in some cases was the saturated hydraulic conductivity. And obviously that's a very spatially varying type of property, which is hard to estimate. But you know, that we found that was the one parameter that probably could be adjusted if we could do a better job of estimating it. It was a little bit, you know, maybe, you know, the hydraulic conductivity was too low and that was getting too much runoff. So by increasing the hydraulic conductivity, we could get more infiltration and less runoff at some of the test sites where we were evaluating wet.
Thanks.
since I've been the whole time sharing my presenter view with the people online, so my apologies for that.
In the beginning, what's regarding tillage, residue cover, or some of these on the government listings. And so, can you, like, when you go out to like the whole state of Minnesota, or some of these other tools, are you able to kind of drill down and see how sensitive those, annual totals are to the specific management practices? Cause I feel like that would be, I feel like that could translate this to a really powerful like management tool, or like a tool to kind of have a proof of concept, like this thing is working on your farm to reduce erosion. And yeah, I was curious because when you show the whole state of Minnesota, like, there was such a tight correlation between the amount of precipitation and the amount of erosion. That it made me wonder, how sensitive those bigger models are to the on the ground management.
Extremely sensitive. That was the idea behind this study. We did a one of a time sensitivity analysis, and basically the moment that we move from a no-till system to the lightest of the scenarios, we see not that much here because you don't have especially like a lot of like high slopes. But the moment you start tilling, especially on those higher slopes, the more is really sensitive to those activity scenarios in those locations.
Thanks.
Yeah. But the problem here is that every field is different in a way. So unless you standardize and force all the hill slopes to use the same management, and again, you have different precipitation too. So we should have the countries with the same precipitation, but you have different soils. So definitely, in terms of hill slope erosion, it makes a huge difference. The more is really sensitive. More is really sensitive to residue cover.
If you follow that, identify where incentivize to maybe say you have this type of slope, or in this part of the state, even probably, those are my interesting.
Yeah, along the lines of this question, if it would be possible on the dashboard to like, say you have 100 hill slopes within your bucket 12 that you're looking at, could you like say what's the average for T1 hill slopes in this watershed versus the average for T6 hill slopes in this watershed? Show that in the dashboard.
Yeah,
that could be kind of cool.
We can.
Instead of a weighted average across all of them, I think what you're saying is you could actually show.
Yeah, I mean, if you have ideas on which kind of information could be useful for conservation practitioners, like what we can put in this dashboard, that would be interesting.
Yeah,
Yeah, I think once we publish that, we can then share that. But until that, if you see these maps, well, we really appreciate your comments. Yeah, well, I moved here like in October, but I found that on Google. Minnesota shade forest. I know. I think it's real.
It is really.
Yeah. So I don't know if it's on the Lake of the Woods or which part of Minnesota it is, but there is. You can Google it. Google it. So forest, yeah. I think that's how it. I don't know why I have that picture.
Oh, there's even an article on NPR. Oh, okay, so I'm saying Yeah.
Yeah.
Oh, way
Yeah.
up there.
Yeah. Good luck if you want to go now.
It's ancient.
That's the.
Ancient alien population.
Saying that you can pay to. Yeah. Yeah.
They did a really good job with the shape, actually. So, yeah. That goes in line with.
Hard to assess their mission. Features that you want to along the contour, you get less erosion.
Yeah.
Up and down the contour, you're gonna get a lot of concentrated flow. Good luck with that.
Yeah, that sounds like an optimal site for like random validation.
Yeah, they won't pay for this.
Yeah.
All right, can we give Eduardo a hand?
Yeah.
Thank you for introducing us to the Minnesota shape.
Well, we're asking random first. It's beautiful.
Yeah.
One of the soil judging students, I think it was Finn, that's what I heard yesterday.
Those are the teaspoons.
Yeah.
In the meeting. Oh.
Oh,
That would make